You're watching the Weiss channel. Da, 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 da. Thank you very much. I'll be here all week. Okay, today we're going to talk about properties of exponents, how exponents work. So, do you remember? Do you remember the time we found? You remember the time we first met? 2x plus 3x is 5x, yes? No problem there. 2x to the second plus 3x to the second is
5x squared.
5x squared, 5x to the second, right? We don't change the exponent, right? No problem there? 2x to the 7th plus 3x to the 7th is,
5x to the 7th.
thank you, 5x to the 7th, right? Negative 2x to the 7th minus 3x to the 7th is negative 5x to the 7th, right? We're all good there, no problem, right? Fabulous. Gucci. Now, what about this? Here, negative 5a to the 4th plus 4a to the 3rd. Can I combine those two?
No.
No. But here's a to the 4th minus 7a to the 3rd. I'm going to combine the like terms, right? Okay. Negative 5a to the 4th plus a to the 4th. That's the same as plus 1a to the 4th, right? So what's negative 5 plus 1? Negative 4a to the 4th, right? And what's 4a to the 3rd minus 7a to the 3rd? Negative 3 minus 3a to the 3rd. There's no more you can do with that, right? Done. Okay? Now, multiplying. Okay? Would you agree that a to the 3rd is a times a times a? Right? Would you agree that a to the 4th is a times a times a times a, right? So a to the 7th is a times a times a times a times a times a times a. You just put it all together and you've got a to the 7th. Yes? So the shortcut is, of course, when you're multiplying with exponents, you simply add the exponents. No problem there, right? Fabulous. The thing is here is students often get confused once I start adding the exponents because that a to the 3rd times a to the 4th is still a to the 7th, but all of a sudden, if I put 5a to the 3rd times 3a to the 4th, people want to say, oh, is that 8? Because I add 5 plus 3? No, don't change the laws of math. Okay? 5 times 3 is still 15. Okay? So 5 times 3 is still 15, but a to the 3rd times a to the 4th is a to the 7th. Everyone okay there? Okay. Same idea here. 7 times 6 is 42. A to the 7th. Okay? What about here? A all by itself. All by itself is a to the 1st power, right?
Yeah.
So 1a is just 1 times 3 times 2. 3 times 2 is 6, right? But a to the 1st times a to the 4th times a to the 3rd, isn't it 1 plus 4 plus 3, right? A to the 8th. Is everyone okay there? I need a big fat nod. Tell me everyone is good. We're good? Fabulous. All right. What about this? Still, 3 times 4 is still 12. That doesn't change. All right? But now we have two different variables, two different letters, right? A to the second times a to the third is a to the fifth. I don't combine that with the b's. I write them separately. B to the fourth times b to the first is b to the fifth. Done. Is everyone okay there? Please tell me if you're not okay. All right? Over here, 2 times 3 is 6. A to the first times a to the fourth is a to the fifth. B to the second, b to the fifth, b to the seventh. We're still good, yes? Not hard, right? Okay. 2 to the third power means 2 times 2 times 2, right? 2 times 2 is 4. 4 times 2 is 8. Right? Okay. But 2x to the third power, would you agree, is 2x times 2x times 2x, right? Does that make sense? Yeah. So what we're doing, it's kind of like distribute, because we're going to take 2 to the third power and x to the third power, right? So if you have 2x in parentheses to the third power, we're going to do, right, 2 times 2 times 2 is 8, right? X to the third. So 2x in parentheses to the third is the same as 8x to the third. Right? Okay. It can get confusing if you're just not careful. Just be careful and you'll be fine. Okay? Over here, the same thing. You do not have to do this step, all right? This is 2x to the fourth times 2x to the fourth times 2x to the fourth, right? What I'm telling you is all you have to do is say what's 2 to the third. 2 to the third, of course, is 8. But what's x to the fourth to the third? That's x to the fourth times x to the fourth times x to the fourth, which is x to the 12th, right? The shortcut is,
Can't you just times 4 times 3?
can't you just times 4 times 3? Thank you, Jesse. Yes. That's all you do, okay? Here, I took 1 times 3. Here, I'm going to do 4 times 3. Just be careful that you don't do 2 times 3, because this is 2 to the third power, and it's x to the fourth to the third power. So here, you just take 2 to the third, but you multiply the 4 times the 3. Are we okay there? All right, very good. So don't let all this mess confuse you. Deal with the parenthesis thing first, meaning you've got 3x squared y to the third times, again, 2 to the third is 8, and you've got, x to the 12th, right? Now let's put it together and say, okay, 3 times 8 is 24. Now, x to the second times x to the 12th. Don't confuse that with this. It's not x to the second to the 12th. Now we're back to this concept here, where we added the exponents, right? X to the second times x to the 12th is x to the 14th. Is everyone okay with that? Y to the third, there's no y over here, so it's just y to the third. There you go. Okay? Once again, I'm just going to deal with the parenthesis thing first. I've got 3x squared y to the third times. I did use the same thing here. 2 to the third is 8. X to the fourth to the third is x to the 12th. And now I've got times x, y squared. Don't let the big mess scare you. It's simply 3 times 8 times 1, which is still 24. X to the second, x to the 12th is x to the 14th, times x to the first is x to the 15th. Yes?
Yeah.
Thank you. Y to the third times y to the second, y to the fifth. Not so painful, right?
Right.
You've been watching the Weiss channel. Da 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 da.